So, with no further ado, I think I've taken 10 minutes. I'm going to hand over to Ben from Microsoft.
Thanks, Alex. And yeah, just to echo what Alex said before, thank you all so much for taking the time on a Tuesday evening to come out and listen to other speakers. I hope I have an interesting talk for you. I'm going to be talking about efficient natural language processing. So fine-tuning small language models using the Azure platform. And those unaware, Azure is Microsoft's public cloud offering. Quick introduction to me. My name's Ben. I'm a data science manager at Microsoft. So I work for industry solutions delivery within Microsoft, which was formerly Microsoft Consulting Services. So what my team does is we create custom AI solutions for Microsoft customers, developing those AI and machine learning solutions on the Azure platform. Now that I'm a manager, I get to do less coding, unfortunately, but and a lot more sales. But it's still a really interesting job. And like Alex said, like the pace of development at the moment in this industry is crazy. It's hard to keep up with everything, even just within the Microsoft platform, let alone outside. I was hoping that no one would bring up DeepSeek because I haven't changed my presentation in response, and yet then it was brought up. But so I put it to everyone here today that for too long have LLMs been taking up the headlines, and at least in the last year, SLMs have been more in the media, more in people's consciousness. So there is becoming a growing trend within AI for people to start to use small language models. And we can see here articles from the Wall Street Journal, Forbes, and MIT Technology Review from towards the end of last year. So what are small language models? So small language models are like large language models, transformer-based models. Since GPT-2 all the way over there, they've been largely decoder-only models, and we're talking, the high hundreds of millions of parameters to the low single billions of parameters kind of area. As we move towards this end of the spectrum, just past September here, so December time, Microsoft released 5.4. So you can see through here we had 5.1, 5.2. Sorry, I inverted the colors, which is why the colors are all funky of the Microsoft logo. 5.3 and 5.3.5, but then we've got 5.4 now, which is 14 billion parameters. And I guess at that point you're starting to get into the realm of medium-sized language models, right? Into the tens of billions of parameters. Because for comparison, large language models, you're talking 70 billion parameters upwards into the hundreds, and even hundreds of billions and even trillions of parameters. By the way, I recommend for anyone that does want to get into small language models, I've got a reference to a paper down here, and I fully recommend that if you are getting into small language models, to read this paper first. It will go through a history of small language models. It goes through architecture. It goes through what data these models were trained on. It goes through like a comparison of different metrics. So fully recommend this survey here. Really good work done by these researchers. Sorry, people were taking pictures of that. I'll put it up for a second. What? Right. So in general, for a generalized set of tasks, a small language model is not going to perform as well as a large language model. So what are the benefits of small language models? So we've got cost effectiveness as the first one, right? So for a small language model, you've got less compute requirements. There's far fewer parameters, right? So training, fine-tuning, inference, all cheaper to do when you're using small language models. Then we've got deployment flexibility. So you may have compute constraints, your hardware constraints. You may be on and networking constraints as well, right? You may be on a factory floor where you may not have internet connectivity, or you may be in a car where you would like to deploy it on an edge device within that car. So in which case you're not going to be able to deploy maybe a large language model. Also coming back to cost, right? The cost of the hardware is cheaper. Ultra low latency. So given the same hardware, you're going to have lower latency with a small language model. This is not just good for when you need a rapid response, but also as we move into an age of agentic applications, right? As the agents interact with one another, the latency stacks, right? So if the latency of one agent and they start talking to each other, and if you have that, that maker checker pattern for an agentic thing, that can take up to 10 minutes or so, just going back and forth between those two. So if you can speed that up a little bit, all the best, right? So ultra low latency of small language models. finally easier to customize. So the main aim of this talk is to talk about fine tuning. So we'll talk about how we can customize these models. So what are some of the applications of small language models? Like I say, offline environments, on device or on-prem, all the iOS devices now have a small language model on device. So where local inference may be needed. Latency bound scenarios where fast response time is critical, and we'll look at one of those in the use cases we look at in a bit. Cost constrained tasks and use cases. Again, we'll look at one of those in a bit as well. Resource constrained environments, and then select tasks can see improved performance via fine tuning versus large models just out of the box. So specialized small language models can perform well out of the box. So this is R-star math. This is, although it's a smaller than LLMs, this is an SLM that can master math reasoning with self-evolved deep thinking. And this is a small language model, and without distillation, which I'll talk about in a little bit, R-star math was able to perform just as well as OpenAI's O1 on a number of math reasoning benchmarks. And it did this through Monte Carlo tree search driven deep thinking. And you can go to this. You can go to the Microsoft research paper and see what the team did there. But it's a specialized architecture. It's a specialized, say, architecture combined with algorithm for doing mathematical reasoning, right? So you're not always going to want to have to go through all of that. That requires a research team and everything. So alternatively, general small language models mainly fine-tuning to your specific task. So fine-tuning refers to customizing a pre-trained model with additional training on a specific task or new data set for enhanced performance, new skills, or improved accuracy. Now, Llama 2 was trained using 170 million GPU hours, right? So this is a lot more feasible with a small language model than a large language model. Where you have specialized tasks that you'd like to do, is much easier to take a small language model and fine-tune it to your use case. So why might you fine-tune small language models? Well, the first one might be that you want to reduce the prompt length. So in your system prompt, for example, you may have things like personas. You may have seen prompts that say, you are an expert at X. As an expert in X, please do this. Right? You could train your model to be an expert with examples that suggest it is already an expert in this. You could give it tone. You could give it a range of knowledge that you could then fine tune into your model, right? You teach it new skills, so skills that weren't in the data sets when the model was trained. So if you're training an open source open source model would tend to be trained on open data sets. You may have a specific data set from your own company that you may want to use to fine tune your model on a specific skill that wasn't used in that generalized data set that was used to train that model initially. Improving tool use. So you may have like functions or APIs that you wish to call, and we'll look at an example of that in one of the use cases we speak about in a little bit. And finally, domain adaptation. Again, we're going to talk about agrochemicals example, but not every single domain may have been trained into this small language model when it was first trained. And also, all of our own companies have like specific niches in which that model won't have seen any previous data about that particular niche or limited set of data, and you want to then fine tune so it learns more. And then there's some vertical specific ones shown here: natural language to code, translation and dialects that it may never have been trained on. Welsh, for example, I'm not sure. Where actually that was a bad example because there's quite a lot of Welsh and English texts online, but it may not have been trained on a specific dialect of some language, for example. Style and formatting and customer knowledge infusion. So I mentioned that paper earlier, and that has got some good information about SLMs out of the box and their metrics and so on, how much memory they take, how much they cost to train and so on. But this is an example of an experiment that my team did. So at the top there, we've got Mistral 7 billion parameter version of Mistral Instruct. And the accuracy on the data here we're using is toxic chat. Toxic chat is used to to detect utterances from users that are toxic. And the accuracy off the bat is 25% for Mistral, 7 billion parameters instruct, and Phi3 mini. 4K actually refers to the token length, not the number of parameters. It's about 4 billion parameters for Phi3 mini there, and the accuracy there was 21%. And with Mistral, we did fine tuning. We did both LoRa and QLoRa. So LoRa is low rank adaptation. Essentially, you stick another matrix in there. That's why it's slightly bigger. You stick another matrix in there and train that one, right? And then QLoRa is quantized LoRa. So quantization is the process of reducing the precision of the weights within that model, right? So that one's a lot smaller because we've reduced the precision of that model. But you'll notice that we've not lost any accuracy when we're using LoRa or QLoRa, and it's a lot smaller. But the accuracy has gone from 25% to 95% with fine tuning on an unseen set of utterances. And with Phi3, we were able to get that accuracy up to 94%. For comparison, as a large language model, OpenAI was able to get 62% accuracy just out of the box. So better accuracy than these two from the base, but nowhere near as good once we'd fine-tuned it on the toxic chat data. There will be a Medium article to follow on this, and if you add me on LinkedIn, I'll be publishing that from the people in my team. So where does fine-tuning fit in? So I'm not suggesting that fine-tuning is the end of it, and fine-tuning will mean that you don't have to do prompt engineering anymore. I'm suggesting it's a complement to prompt engineering. So you will still be doing your prompt engineering. You'll still be doing maybe retrieval augmented generation from your knowledge base from within your organization, but you can fine-tune the small language model to reduce the length of your system prompt, show, not tell the model how to behave, improve accuracy when you look up information, and improve the model's handling of retrieved data. Right? A lot of the time, you're getting a lot less hallucinations because it knows what to do from the information that's given to it. These are some of the considerations you might take when fine-tuning small language models. We do have an out-of-the-box solution for fine-tuning small language models. So you can just, have an API, provide it with a whole load of examples, and fine-tune a small language model just without having to do much yourself. Almost everything's managed for you, or you can use managed compute, and we can do a custom fine-tune. And then you've got a whole load of different things available to you, right? Not every small language model is going to be in the out-of-the-box example. And if there's a new small language model, for example, that might not be in the out-of-the-box solution already, right? Then, as I mentioned, there's model quantization, so you may want to reduce the precision of your model so that you can be more efficient in terms of speed, in terms of cost, without reducing accuracy by that much in a lot of cases. You may want to try out different tokenization mechanisms. The way you prepare your data set, you could do differently with your custom fine tune. You could do a full versus partial fine tune. And so the way that you do, well, you could do low ranked adaptation. You can do another fine tuning technique. These are like parameter efficient fine tuning techniques. You could use custom metrics. So it may be the metric that's out of the box is not the one you're looking for. And we'll talk about a little bit metrics on the next slide. And then, you can do high parameter optimization on the fine tuning mechanism that you choose. So when I talk about evaluating model performance, there are a whole bunch of metrics that you may be interested in. And the first ones there are more, non-functional metrics. You've got like throughput, first token time, inference latency, and memory usage. But then we've got like AI metrics that include groundedness, similarity, relevance, fluency, and coherence. And we do have these in a Git repo. We do have them on Azure AI Foundry, but you will find them in your favorite, AI application or generative AI application framework. If you're using, Llama Index or LangChain, you'll find very similar AI metrics. Then we've got traditional metrics like F1 score, Rouge score, Blur score. I'm assuming that's how it's pronounced. I've never actually spoken them out loud. But we got those traditional metrics, and then function calling. So if you're doing function calling, there are specific function calling metrics, and that may be what you're interested in. And we'll see an example of function calling in a few slides. And then we've got responsible AI metrics, and I'll come back to these a bit later because we do have responsible AI metrics built into Azure AI Foundry. One thing I do want to talk about before I move on is distillation and data generation. So of course you can have a whole load of examples generated by having experts write down like loads of different questions and loads of different answers and have them all able to then be put into your small language model. And that may be the only way you can do it. And particularly if you've got like a historical corpus, maybe you have, if you've got customer service, you may have your history of customer service chats, and you can use that to fine tune your models. But some cases you may not have data, right? And if you want to, you can create data using a large language model and use that created data from the large language model to train your small language model. So if there's a large language model that's particularly good at the thing that you want the small language model to be good at, you can create synthetic data from the large language model and then use that to knowledge transfer to the small language model. And this is an example of a model that used information that was synthesized from not just one large language model, but a range of large language models. And it used that to learn how to reason. So then these reasoning metrics, Orca 2, then was just as good as some of these others, like Llama, Wizard, these larger models, like the 70 billion parameter models, on a whole bunch of reasoning tasks. And that was from 2023. But it just shows that you can use distillation to get almost just as good a performance as a large language model on a specialized task. So I hope that gives you a good introduction as to what small language models are, why you might use small language models, and how to. I didn't go into the depths of how to fine tune them, but some of the considerations you might have to take when you fine tune them, and how you can create data for fine tuning them. So now I'm going to talk about some use cases, like real world use cases that Microsoft and some people on my team have worked on. So who here? I'm going to ask for a show of hands. Who here drives? Okay, about half the people. So those of you that don't drive, let me just tell you that it is sometimes a frustration that you're driving and you can't, there is a knob down there somewhere to turn on the aircon or the heating, or you want to change the radio station and you're like, it's one of these buttons on the steering wheel or it's on a screen. Exactly. I don't want to be like driving and trying to turn on things and off things. So it would be much easier if you could just speak to the car, right? And so we've fine-tuned a small language model that can then be put on a car so that you can just say, hey, Mercedes, as it says on the screen there, and then you can say, turn up the air conditioning for me, or, turn on the heating to 22 degrees, or change the radio station to X, or can you direct me to Y, or can you find me a petrol station on the way? This kind of thing, so that you're not like fiddling with your GPS as you're driving. So we fine-tuned a small language model on function calling so that when you speak to your virtual assistant on the car, it would process your voice, turn that from speech to text, and then the text can be passed to the small language model, and a small language model can decide, okay, what function do I need to call here? Do I need to call, the function for turning on the heating, or turning on the air conditioning, or changing the radio station? And then what parameters do I need to pass to that function? And then this could be put on, onto the car itself. And then, people can, when they're driving, they can speak to their car. So I have a little video of this.
Hi, greetings from the Silicon Valley. Let's check out Hey Mercedes, our in-car speech assistant for MBUX-equipped vehicles. Since this June, we've been the first automaker to integrate ChatGPT into cars as part of our beta program for our US customers. So let me show you. Hey Mercedes, I have some time this afternoon and would like to explore San Francisco. Any recommendations?
Here are some recommendations for you. Visit the iconic Golden Gate Bridge for stunning views. Take a drive down Lombard Street, known as the crookedest street in the world. Explore the Ferry Building. Visit Coy Tower for panoramic views of the city. Enjoy your exploration of San Francisco.
Great! After this, I want to drive down Highway 1. Are there any nice beaches along my way?
Driving down Highway 1 will offer you breathtaking coastal views, and there
So
are
in America, you can get the Hey Mercedes on your car now, yeah. So this only showed the GPS, which you would call over the network, but there are local things that you can call, and of course, you don't want if you've not got internet connectivity, you don't want it to call over the internet, right? And to turn on your heating, for example. So there are local and remote functionalities. And this was worked on by a whole bunch of people within Microsoft Consulting Services. Another example is, so Bayer are a biotechnology company known for pharmaceuticals. So they were the maker of aspirin, but also for agricultural chemicals. And they've created an assistant called ELY, which is, I think, Expert Learning for You. And their aim is that every farmer, regardless of location or resources, should have the agronomic expertise needed for their success. And they found that small language models considerably improve performance, cost, and accuracy of ELY. So what's shown at the top here is an output from GPT-4o Mini without any fine-tuning. And you can see that the answer actually doesn't answer the question, what is the charcoal rot score for that product there? But after some fine-tuning of a small language model, what the answer for what is a charcoal rot score for that given product, we can see that it's given as 3, and it's a lot more complete answer, and it's a lot more accurate answer. They found that the responses had improved accuracy in 40% plus of questions compared to GPT-4o Mini. And 50% more responses from ELY are consistent over 10 runs. So that's another thing that was very important to them, is that the responses that they were getting was a lot more consistent, whereas the answers from GPT-4o Mini were, very different from answer to answer when you're asking the exact same question. And there was a whole bunch of value creation metrics that Bayer got out the back of this. And Bayer and Mercedes are not the only 2 organizations using Azure AI today. So now into the Azure sales pitch, but I promise you, it is a nice platform to use. But there are a whole load of organizations, 60,000 plus organizations using Azure AI today, and just a few of them are shown on the screen here. And I would like to show you Azure AI Foundry, which is our unified AI platform for training models, deploying models, creating AI applications with different prompt flows, with different agents, and so on. And I implore you to go and have a look at it. But
it's about you, and them, and them. Every developer, the builders, the implementers, the groundbreakers. The power of AI is yours. So select models confidently, test them, compare them, and find your best fit. Activate diverse data from any source, in any form, and turn it into reliable intelligence. Customize models with retrieval and fine-tuning to deliver performance that stands out. Safeguard every layer with trustworthy AI from the start and protect against new risks. Design personalized experiences without boundaries, always learning and adapting. Innovation prompts more innovation. It doesn't stop. It only gets better. You're creating the future, and Azure is here for all of it. Keep iterating, keep scaling. Be unstoppable.
Talk to your own chatbots from within Teams, right? And you can include them in conversations with people. Then we've got Visual Studio, so integrates with Visual Studio Code. There's extensions for Visual Studio Code. Everything integrates with GitHub, and then we've got the Azure AI Foundry SDK. So for all of you developers out there, that want to interact with it just using SDK, more than welcome to. Everything's tracked within Foundry. You can always go in and have a look at the UI, but if you never want to, you don't have to. And like I said, Azure AI Foundry is an open and modular platform. It works with the entirety of the Microsoft cloud, but it also works with other collaborators, some of which are shown here. So including weights and biases, so you've got that nice model training, model tracking, and that comes with that. And our brilliant sponsor Selden fit in over here with the orchestration. With the orchestration of model deployment, scaling your models, and we're using Kubernetes and so on, and the monitoring. So yeah, works with the Selden stack. So if you want to use Selden as well as Azure, great. I mentioned there's a model catalog and the whole range of models in there. And you can pick which model you like just out of our catalog and go, okay, I'll fine tune this. And we have a support for a massive range of models. So we've got over 1,800 models on Azure AI Foundry. These cover the OpenAI model family. And it's not just language models. We've got multimodal models as well. And we've got models that are already fine-tuned for specific industries on there. I mentioned Azure AI content safety. So we've got this tool on Azure AI Foundry for content safety. So harmful content such as like sexual content, hateful content, violent content can all be detected, and you can like turn the knobs as to how specific you want that to be to your application. Then there's groundedness detection. So is the answer that's being provided grounded in the data that's being provided to your language model? We've got prompt shields to prevent from like prompt injection, leakage, and so on. And then we've got protected material detection. So if someone's asked for, a Taylor Swift song, for example, then you can detect any copyrighted material before you send it back to a user. Now, to bring it back to small language models, so in Azure AI Foundry, we do have a couple of options for fine-tuning SLM. So as I mentioned earlier, there's the out-of-the-box serverless API, the models as a service. So it's really easy to use. You just provide it with your new examples to fine-tune your small language model, but you get a lot less granularity with which you can control that. And I showed like those different dials that you might want to tune, which like things like quantization. You may want to use LoRa, you may want to use some other fine-tuning technique, right? And you may just want to experiment and see which one's best for you. And you can try a whole different range of models as well. And so we have managed compute. So again, you don't have to manage the infrastructure in this case, that's managed for you, but you get a lot more control in training your models. So some conclusions. Small language models are faster, smaller, and cheaper than large language models. Small language models can be fine-tuned for specialized tasks, and upon fine-tuning, they can perform just as well, or in some cases better than large language models. There are out-of-the-box or more custom options for fine-tuning, and Azure AI Foundry is a comprehensive, unified platform for creating AI applications. I just want to give some special thanks to particularly Liana, who is my colleague that is far more experienced in this than me. Like I say, I'm a manager, so I don't get to code much, but she is the brains behind most of the stuff that I've shown today. She and this team down the bottom here are the team that was on Hey Mercedes. And this team in the top right here are the team that did that custom fine-tuning that I showed of the Mistral and Microsoft the Phi 3 model. So big thanks to these people. And finally, I just got some resources at the end here. But yeah, that's it. I hope you enjoyed this presentation, and thank you so much for taking the time to listen to me. Please feel free to add me on LinkedIn, and I will be posting when that Medium article is available. And also, Liana and this team down here are working on a small language model fine-tuning accelerator, which will help anyone that wants to do their small language model fine-tuning on Azure using a whole different range of fine-tuning techniques. That will be released in the near future. It is in internal beta at the moment, but it will be released, and I will be publishing that on my LinkedIn as well. So please do feel free to add me on LinkedIn. My name from the beginning, Ben Keane. And yeah, I'll be publishing those two things on there. So yeah, like I say, hope you enjoyed that, and thank you for listening.
Great. Thank you, Ben. Well, what a talk. It's just amazing to see how far Microsoft has come over the years. You know, for the developers and the people who've been around for longer, you know, Microsoft didn't have, you know, a good reputation among developers in the olden days, you could say. And it's just incredible to see how much you've embraced open technologies. You can run Linux within Windows, open source, AI investments and integration. So, you know, the amount of technology that we have at our fingertips now through platforms like Azure, through all the open source and source available tools which are now, you know, accessible, means we can really, you know, build incredible things in such a short space of time. It's very exciting. We've got a few minutes before kind of a brief networking break whilst we switch speakers. But if anyone has any questions for Ben, yeah, feel free to put up your hand now and we can take the microphone around and ask a few questions if that's okay. Good. Yep.
What experience have you had with training SLMs with synthetic data?
Personally, or just at Microsoft?
At Microsoft.
So I showed the Orca 2 model, right, which was from Microsoft Research, where we use that distillation using then the synthetically generated data from large language models through to a small language model, right? And that tends to be like a similar pattern that we can provide some examples as few shot examples to a large language model and say, generate me 1,000 more of these, right? And you know, mix it up with X, Y, or Z, right? So you can generate the synthetic data from a large language model by giving it a few shot examples. So once you've got it, because experts, one, very expensive, and two, very busy, right? So as long as you can get a few examples from them in the format, like question, answer, this is why this answer was good sometimes, right? Then you can, as long as you can get like quite a few examples of those, then you can pass those in as, here's some examples of good examples, give me some more to a large language model, and then use that ultimately, like I say, through the process of distillation to train your small language model. It is a common pattern that we're with almost all small language model training that we have to do, just as a result of the fact that, yeah, like experts are expensive and busy. Yeah, so what we tend to do is we'll tend to generate a whole bunch and then just ask them to review it and go, does this look fine to you? Or like, so yes, sometimes then ultimately, whether you're using a small language model or a large language model, there's going to be hallucinations that are incorrect, right? But yeah, if you can, I guess, provide it with as much information as possible and ground it in things like manuals and so on, then hopefully that should help. But yes, we do see hallucinations just as the nature of it. But yeah, we do try and get the experts to review it before we go, okay, now let's train our small language model, because, you know, garbage in, garbage out, right? If for one incorrect input, you may have to give it 10 correct inputs just to drown that out, right?
Hi, can I ask, you know, in terms of in small, because up till now we've been dealing with large language models, yes? But as you're saying that small language models are much more, I would say, a compressed form maybe of the larger ones, right? Okay. So whereas I understand in the large language model, the main data source, okay, would be there or uploaded in their complete entirety, right? But in the small language model, would the data source be the same as a size, or would that be slimmed down slightly or not?
So what you find is, I mentioned that that review article early on, right? And what
I didn't touch on that.
Oh, no, I didn't talk about the data sizes or anything like that. So it's a good question. So what you'll find is when you're training a small language model from scratch, then the data tends to, I think it's called the chinchilla ratio or something like that, which is the ratio of parameters to tokens that you train your model on. And for small language models, they tend to be overtrained relative to that chinchilla ratio of about 20-1, right? So in terms of tokens, you're sort of aiming for 20-1 in terms of 20 tokens per parameter of training data. Now, the data that you actually use is different or the data that's been used is different per model. And you can go into that survey and you'll see a whole bunch of data, like open source data that has been used to train each of those models. You'll find there's about 12 data sets that is really common across models. But each model will obviously have its own set of data. I know there's like less redundancy when you come to small language models, because when training, I think when Databricks trained, or Mosaic, I should say, trained their large language model, they used like Wikipedia something like 10 times or 12 times into the model. And there's less of that redundancy when you're training small language model, just because generally, just because you don't want to necessarily overfit to anything.
Thank you for that. Just one small point.
Yeah.
So for example, you're just saying that. So in essence, actually, you're also saying that because the data, the whole entire data set would be uploaded onto even to these smaller language model, yes,
yeah,
in its entirety. So that means that, in essence, the actual AI model itself should be much more accurate, isn't it? If I'm not wrong, or maybe if I am, could you enlighten me? As in the large language model, right?
So I guess it depends what you mean by the large language models tend to perform better on a generalized set of tasks. If you generally on a generalized set of tasks, because they've got because you've given them such a breadth of knowledge, and even in different contexts, like the same words within different contexts, same tokens within different contexts, so it gets a better understanding of the human language, just because it's seen a lot more, right, than a small language model. But it depends what you mean by accuracy, because of course I showed that math one where it performs just as well as O1 on math reasoning, but then it's very specific to that task. So I guess it depends what you mean by accurate, but it tends to perform less well on a generalized set of tasks unless you fine tune it for something in specifically, because the small language models are also generalized, but just not as well as the large language models, right? Sure thing.
We have time for one more question. If anyone else, yeah, at the back here. Speaking to the mic for the people online.
Thank you for the talk. So you mentioned that some of your customers were deploying models that would run on device, right? I think in the Hey Mercedes feature, some of that was running locally.
Yeah, so that will run locally, and then it will call, if it's required to, for example, the GPS stuff, it will call like a remote API.
Yeah. So I was curious though, if you're seeing any customers deploying on device, but where the target devices are like typical consumer hardware, like phones, laptops, that kind of thing. Do any customers or use cases come to mind there?
Well, I guess we as Microsoft have a whole set of machines now that the core of Copilot is supposed to be running on the machine, and there's a Copilot button, right? So internally we have that. Thinking externally about consumer devices, it tends more to be things like a Jetson Nano, rather than I can't think of off the top of my head any examples where we're using consumer hardware and we're deploying on there. But ultimately, as a consultant, we tend to be doing point solutions for a customer, and it tends not to be necessarily for like their customers so much. So I imagine it probably definitely is done within Microsoft, just maybe not within the consulting space where I work. Microsoft, of course, absolutely massive organization, and I know like this tiny sliver of what's going on.
Yeah, we will all have our own small language model tailored to our experience, our data. I think it will be something that will be deeply personal and not something that people want to share openly with others. So yeah, really exciting space. And yeah, this small language model is just opening up a huge range of opportunities, which we'll see encourage anyone here today as a takeaway to just think about how you can apply this within your organization and your projects. So thanks again to Ben. Fantastic talk, great opener for this evening. Everyone give him a quick round of applause, and we will break for about 10 minutes.